Hi there, I'm Nate Adams, often known as Nate the House Whisperer, and I have been playing with energy monitors for years now. Forget when I got the first one, something like 2016, somewhere in that ballpark, and a project that I helped out with had an e-gauge back in 2014, but I wasn't really that involved in that one. But I've been playing with these and watching them for a long time. And what's cool is the prices of these have just fallen off a cliff. So it wasn't that long ago getting a monitor that had 16 CT clamps. You'd be looking at an e-gauge for something like $1,000, or the Energy Detective for similar kind of ballpark. There is a newish product out called the Emporia View, which is what we're going to look at here today. And I'm going to compare 3 different houses in very hot weather, because we just finished 2 days of very hot weather, upwards of 90 degrees. And I am sitting here now in West Virginia. So like the Game House and Mountain Escape, these are both in West Virginia. So Mountain Escape, where I'm sitting now, is in Fayetteville, right on top of the New River Gorge National Park. And the Game House is in Oak Hill, 5 or 6 miles from here, also very close to the park. River House is outside Cleveland, Ohio. It's on the upper Cuyahoga River, which is why it's called what it is. This has window units for now, because ironically we saved up money to put HVAC in this house, and then we bought this one with the money. So it doesn't have HVAC yet. And then ironically we put HVAC in this one, the Game House, and then the soon-to-be Candy House, which is another Airbnb that we are putting together. So the Game House is an Airbnb. But this Emporia product, it's $150 as I'm recording this, which is remarkable, because we went from $1,000 for the e-gauge or Energy Detective. Curb came out at $600 price point. Sense came out, which you can see I also have up here, and I have another video that I just recorded comparing Sense and Emporia View, which I pretty strongly prefer the Emporia. But the Emporia is down to $150. So we've gone from $1,000 to figure out what's going on with the electricity in your house, which doesn't make much sense really for most people to spend that much money to figure it out. It's a curiosity thing. But now we're under $200. And at this point, if you're curious, it's probably worth the $150 in the hour or two that it takes to install one. Or if you have a major energy hog that you're trying to figure out what it is, this can probably help you find it. I hate to talk payback, but if you've got really high electricity bills and you don't know why, for $150, you can probably figure out what's going on. And it wouldn't surprise me if you can get that $150 back fairly quickly. So it's nice to see this. But I also really like using these devices for understanding what's going on in a house, and particularly how is a piece of HVAC operating, because I'm a nerd on that, because I want equipment that runs as long as possible at the lowest level possible. And so we've got some interesting comparisons here. The River House it's not going to be super easy to see because it's got 3 window units right now. But Mountain Escape, where I'm sitting, this has a Bosch heat pump. It's a 2/3 ton, which is really too big for this house. 2 tons will heat it, and it needs only like a ton and a half for cooling tops. And the Game House has a 1.5 ton Daikin Fit heat pump that we just got running about 2 months ago, thereabouts. But it's fun to look through this. So we're going to look at the operation of these different houses. Let's go back to home. And so I like at the bottom here, you see there's second, minute, hour, day, week, month, and year. Second is what the normal view is, and you can see what things are pulling right now. So there's these 3 houses and how they're running as I'm talking. So they all happen to be relatively similar in pull. It is 85 degrees-ish outside, so it's a fairly warm day, but it's been upwards of 90 the last 2 days, which should be pretty easy to see here. Now, important notes, Emporia doesn't save your short-term data very long, so it's only a couple of hours to a couple of days. I think it's a couple of hours of your second data and a couple of days of your minute data. So if you want to see what's going on, you have to look pretty shortly thereafter. And seeing how things are running like right after particularly a hot spell is really useful because you'll understand how things are running. So let's start with the river house for giggles. And so I'm going to click graphs at the bottom here. And then we'll look at hours so you can see what's going on. And it's relatively consistent here. So it's got smallish air conditioners that are just kind of pulling all the time. Oh, wait, look, I didn't notice. This is river house refrigerator. So we want to click over here, graphed circuit. And we want to look at the main for the river house because it's got those window units. And you can see what it has been pulling over the last 24 hours or so down here. And so this makes sense as the house got properly cooled down after a hot day. You can see the energy use dropped. And when did it come back up? About 9 in the morning. That makes sense. So the sun came back out, started warming the house up again, and the ACs started doing their thing again. So we're looking at a kilowatt hour and a half. So was it 1.5, 1.7, 1.8? Looking up over here at how much it's using hour by hour. But you can go back and kind of see what's going on. But the minute data can also be really useful. So you can see peaks and valleys of when things are running. Now, this isn't super easy to go back and look at historically, but you can. So if you click home, and so here's River House, you can look at the last hour and see where things are pulling from. So total usage is 630, and then I can pull down here. It can show you what the balance is. And this is kilowatt hours over the last hour. You have to look for that, where that's hiding. Oh, energy use in kilowatt hours up here. So this is 0.326 kilowatt hours that were not clamped, which is going to be the other air conditioners, because I didn't clamp every circuit that the air conditioners are on. But my office, that air conditioner is pulling from that, and it's used 0.2 in the last hour for that. So you can get an idea of where things are pulling. The refrigerators used a little tiny bit and so forth. But we can click like a day. So this isn't going back 24 hours. This goes back to midnight is how this works. So this is the day that you're looking at. So I'm recording this at 1:30 in the afternoon. So this is 13 and a half hours of usage. So the house has used 17 and a half kilowatt hours, and it's sitting open right now. There's somebody coming in today, but somebody left 2 days ago. And so you can see what's going on there. So this is the air conditioner in my office, which is obviously pulling most of the juice. Although, no, that's not true. It's just most of the track juice. So at the bottom, look, there's 9.8 kilowatt hours balance of the 17 and a half. Yeah, so the air conditioners are pulling the vast majority of what this place is using right now. So the the refrigerator's using a little bit. The water heater on standby uses like a half a kilowatt hour per day. So this is, 5 cents a day, 6 cents a day of just standby losses, meaning the temperature in the tank just falls naturally over the day, and it needs a little bit of heat to push that back up. This, at least right now, it's cooling, so it actually helps things a little bit. I can't see the dehumidifier anymore. See the dehu down here? It has a smart switch, and the smart switch kicked the bucket like 2 weeks ago. Of course, it was like 3 days after I stopped up there. I could have put another plug on it, but oh well. But you could see what that was doing. Like if I look at the last month, whereas the dehu 3.3 kilowatt hours for the last month. So it's just kind of nice that you can see all of this. But so month is kind of useful. We're halfway through. So 400 kilowatt hours so far this month, 51 from the air conditioner in my office. And if you look at the balance, 200, some of that's going to be people using power, but most of that is probably going to be from the air conditioners. So we have 200 there, 250 here. So we've got a decent chunk of cooling. So what is that? $30 so far it's cost to cool that house for the month, ballpark. So 250 kilowatt hours times 13 or 14 cents is 30, maybe $35. So it costs like $70 to cool for the month, and it's been pretty hot, I have to say. So we've been running a bunch of cooling here so far. It's been August weather, considering it's the beginning of June. But anyway, you can kind of see where all of this stuff is, what the washer's been using. I was like, what's going on? Why are these running? So there must have been just enough cool weather for a couple of days to burn some resistance. It's resistance heat, and it gets pretty painful. In fact, I can look at graphs. This is the River House main. Take a look going back to the winter, 3,300 kilowatt hours, which is over $400 for the month. So that was painful. So I'm glad that we had some people in there to cover that cost. But that is, it stinks. It's your low occupancy time of year. And typically you have your prices pared back some so that people actually come. And then you have your highest operating cost. So your margins are definitely not that great for January, February. Is what it is. You have to say it's a pretty place to be right on the river there. When there's snow, it's really quite nice. But anyway, you can get an idea of where the usage is doing this. So back to the air conditioning. Look, let's switch back to home, and let's go compare. So the River House is 250 kilowatt hours or so for the month for window air conditioners. So Mountain Escape, we can pull these out. So here's the heat pump. Actually, this view is better. So if you remember up here, this is the River House, 50 plus another 200, so about 250 kilowatt hours for cooling. This is my Bosch heat pump here at Mountain Escape, and it has used 118 kilowatt hours, which that sounds really, really good. The bad part is this unit, I've got to do some settings changes. It is not dehumidifying for squats. It's cooling, but it's not dehumidifying. So washer here also has the dehumidifier plugged into it. So that's the curse of this is conflating the two. But the vast majority of this is not the washing machine. It is the dehumidifier. So let's say it's like 120. They've been running very close to equal. The dehumidifier is pulling as much electricity as the heat pump, which is the air conditioner. So we're looking at 240 kilowatt hours for doing this house. And this is 1,150 square feet. The River House is 1,400. And then I'm going to show you the Mountain Escape, the Game House, which is only 800 square feet. But let's take a little bit more granular look. So I will click heat pump. And so here's what it has used. So actually this is interesting. It used 1,150 kilowatt hours back in January. In fact, let's take a quick look just while we're at it. Let's look at the entire Mountain Escape. So we had a 3,300 peak for the month. Up north. So the River House used 3,300 kilowatt hours, and it is a much worse shell, and it has a heat pump water heater, which should somewhat reduce how much it uses. Yet this house, even though this has a much worse shell in comparison, because it has a heat pump, we used almost half the electricity. And this was with a resistance water heater, which is now a heat pump water heater because it leaked 2 months ago, and I had to replace it. So anyway, just quick look at that. But heat pump, let's see how it operates. So let's look at minutes. What I like about this particular unit, if I can get it to do better dehumidification, I'm going to be a lot happier with it. But I think if I get it to do better dehumidification, it's going to run at a higher rate and it's going to function more like a single stage air conditioner. So I'm curious to see how that works. But ballpark, see up here, 739 watts. Ballpark every 1,000 watts is about a ton of cooling. So most people have a 3-ton air conditioner, so it's going to pull about 3,000 watts when it's on. That's the most common size. You may have a 2-ton, which will pull about 2,000 watts. So this is a 2/3-ton unit. It has a switch on it where you can limit it. but it drops down to 700 watts or so here, and I've seen it as low as 600 at times. So here it's running a little under 700. But look how it's there's a nice ramp up here. This is about an hour ago. So it was losing the war a little bit, and it ramped up how much it used. This is what an inverter air conditioner looks like. It runs up and down, where if you look at a traditional air conditioner, they're rock solid. They pull what they pull. They have a big spike when they turn on, and then they pull what they pull. They don't vary hardly at all. Maybe a couple of watts, but like see, we're down to 686 here, and we're up to 1374 here, and this will run up to 2000 watts. But I haven't seen it had to go that far. Although, like, it would be interesting. So here's the last 24 hours. So look, yesterday it was quite hot. It was 95 degrees out. And it was using about a kilowatt hour per hour, which means 1 kilowatt hour is 1,000 watts for an hour. That's what it works out to be. A kilowatt, which is 1,000 watts for an hour, is a kilowatt hour. So this tells you that it was running at 1 ton of capacity, basically 1,000 watts of capacity for those hours. And you can see the middle of the night down here. What was showing 9 a.m. It started to turn on again after the sun had been out for a little bit. But see, the middle of the night, it's not hardly running, and that's when you have dehumidification challenges. Then the day before was also very hot. And so middle of the day, it was running along all day at a relatively low rate. So the bad part is Sense will let you zoom in and out to look at your highly detailed. This you have to slide over, and you can get to where it doesn't let you see anymore. But here's yesterday when it was really hot out, and it's just kind of running along at like 900 watts. Then unfortunately the dehumidifier was in here running along at like 500 or 600 watts all day as well, pulling a similar amount. And here we go. Look, it's middle of the afternoon. We got up to 1200 or so for a little bit there. But note how this is just running and running and running. This is what you want to see. So you need a right size system that turns down quite a bit. This is still really oversized for the house, but there's 2 choices for this particular product. You can have a 2/3 ton or a 4/5. Those are the options. There's nothing smaller. And I wanted to try out this product, so I bought one. Here you go. Here's kind of an interesting ramp where you saw it ramp up and then shut off. So this is actually not ideal programming. I would much rather it start off pretty low here. Yeah, look at that. It kind of freaked out. So it got up to 1700 watts and then shut off. So I would much rather it be flatlined, more like what you see over here. So this little bit here is what you don't want to see operation-wise. Actually, take a screenshot of that. Oop. Other way of doing a screenshot. So anyway, it helps give you an idea. And so this heat pump's used 119 kilowatt hours so far this month. And so at 15 cents, that's, I don't know, $16, $17, something like that. So not that expensive. But again, the dehumidifier is used a ton. So here's how you see the Bosch. Like the Bosch is doing a pretty good job of just running at a low rate all the time, but its low rate is 700 watts or so. So let's go back to home. And then we will go look at the Game House, which has a 1.5 ton unit, although it really has a bigger compressor than that in it, but it's rated at 1.5. And you can see right now it is running at 900 watts. So this is the minute by minute. But let's go see what it was using. So the River House had used 250 kilowatt hours for cooling so far. The Mountain Escape had used 120 for cooling, but also 120 for dehumidification. The Game House does not yet have a dehumidifier there. But let's see. I need to click month. And the heat pump there has used 114. So the usage between these two houses for the heat pump is almost identical. So here's 114. Here is 118. But then we have the dehumidifier as well on this one. This house doesn't have one. And this is, the Mountain Escape is 1,150 square feet, and Game House is 800. It also has 800 square feet of garage underneath it. It's funny. Technically it is the garage for the house next door, but it's actually bigger than the house next door. The house next door is tiny at 670 square feet. That'll be the candy house soon, and I'll be putting an Emporia on that soon as well. But let's take a look at how this works. So their energy use between these two looks relatively similar, but there's been a lot of dehumidification needs at the Mountain Escape, where Game House, this has been doing a good job. This Daikin Fit's been doing a good job on dehumidification. I've been impressed. So here we are. Here's the monthly consumption. We just got that running back in April. So we have all of May at 124 kilowatt hours and half of June at 114. And I mean, pretty routinely, most homes only spend a couple $100 in somewhat normal northern climates, a couple $100 a year for air conditioning. It's not a big deal. You get down south and you can spend that in a couple of weeks. So, but let's take a look at minute by minute runtime. And this one's relatively similar in its output, interestingly enough. But again, it's been fairly hot. And let's see, what's the lowest that it runs at? So this is what I think is cool. Look, it drops down to 300 watts at minimum, which is almost nothing. So that's like a third of a ton. That's really, really low. Now it's a 1.5 ton unit, so that's good. It's a little tiny guy. In fact, the air handler is so funny. I look at him like, when I grow up, I'm going to be a real air handler. They're just so small. The fan's tiny. The coil's tiny. But that I've been really impressed with how it runs. So let's see if we can. Let's slide back. This is just 22 watts. This is the pan heater. Oh, that's interesting. So it ran for a pretty good while, around midnight. I don't know why it did that really, but it did. And you can see it running through the day. That was the evening there. Well, let's get back into the heat of the day yesterday. So it was running along. I think this unit is basically limited at a ton or thereabouts. So there's 1,230. So interestingly, its wattage consumption is pretty similar to the 2-ton here, but it can't go as high. And then it has a boost mode, which lets it into more capacity when you get to a certain temperature. And actually, we should have been there yesterday, but it didn't need that capacity, or it would have used it. So here we're off for a pretty good while. Oh, you know what? So the day before, my daughter and her friends hung out at the Game House because we didn't have a guest there at the time, and they turned the air conditioner down to 63. And I was like, what is going on? So I caught it the night before, but the house was so cold that it took it like 12 hours, even like on a very warm day, to actually come up. So you can see, like, this is 9 o'clock. It's just running its brains out because it was trying to hit 63 set point. That's just silly. It's what happens when you send a couple of 9-year-olds over. And it's just wild. Yeah. So, okay. So you can see when she went over with the energy monitor. So she went next door about 11:30, and she must have thought that it was too hot, and they turned it down to 63, and then it just ran and ran and ran. And they did this on a 95-degree day. Going to be a bunch of grid operators out there that are horrified to see this. This is exactly how you shouldn't do it. But notice, like, this thing, it ran all day long. Which is really awesome to see, actually. And then once it finally started catching up, so she turned it down at 11:30, and it took until 10 o'clock at night before it could fight that down with the relatively low capacity that it has, from 72 set point to a 63. And then it finally ramped down. But note how it's running nice and flat here too. And it must not have been doing quite pulling the temperature down enough for its satisfaction. So you can see where it ramped up just a little bit here, and then went back to like 600 watts, 600, 600. We're into midnight. And the thing's still running because it's trying to keep the house really, really cold. Drop down to 500. And then to 400 at like 2 in the morning. And for whatever reason, there was a little boost of heat there. Then we're down under 400 watts. So like how this one operates and how it's running and running and running, this is what you want to see because it's pulling almost nothing. So you may be like, oh, geez, it's on, but it's on at 350 watts. This costs like 30 cents an hour to run, whatever. It's not a big deal. And then finally at 5 in the morning, it shuts off. And then I checked on the app to see what it was doing out of curiosity. I'm like, why is this set to 63? Maybe it was later when I caught it. Let's see, where was it? So I shut it off at 8. I turned the temperature up. And so 8 in the morning, it was 63 degrees. And it may be jumping here, but look at the top. It's only 40 watts. This is the pan heater. Keep the thing from being wrong. And so it was 8 in the morning on a 95 degree day until 2:15 before the air conditioner needed to turn back on. So it took that long to come up 10 degrees. And this is a 90 degree day. And this house has an okay shell, but it's not great. I partly just wanted to see what happens when you put a heat pump in just an okay shell, and then the candy house is just downright bad. It doesn't have hardly any insulation in the attic, and the walls are empty. The only thing I'm going to do is fix the crawl space / basements because I want to reduce how much moisture comes into it. But otherwise, I'm just going to leave that shell mediocre and see what happens next winter. Partly because I don't want to spend the money, and partly because I'm curious. And I can, so I'll try both. But you can see this thing, once it needed to start running to hold that temperature at 71, 72, whatever it's set at, it was running along, and then look, it dropped down to it's under 400 watts, and then it shut off for a while and kept going. But it's just interesting to see how this unit runs, and I like how this unit runs better than the Bosch. The Bosch does okay, although the Bosch in heating, it's on-off, and it's annoying. It's like a single stage in how it works. And to get it to dehumidify, I need to force it to run a colder coil temperature, but it also sounds like it makes it so that it runs it at higher capacity. So I'm going to turn that on soon, and then I'll see what happens. But this is a rather nerdy comparison of these three houses on hot days to see what's going on. And actually, we should look at what's the daily usage between these. So far today, we are at 4.4 kilowatt hours for the game house heat pump. And there's nobody there right now. It's set at like 71, 72. We're at 5 for the heat pump here where I'm sitting. And then up north of the river house, so there's 5 there and 10 there, so we're at like 15. So it's using a lot more juice, and it's probably, ironically, even though I'm well south here, this is up in the mountains just enough, about 2,000 feet of elevation, that it's not as hot here oftentimes, which is just remarkable to me. We moved south so that the winters would be gentler, and they are. This was the easiest winter I've experienced in my whole life by moving 5 hours south. But the summers are also a bit milder, which surprises me. So this is a nice climate. I like it here. It can be humid, but it's not super hot and it's not super cold, which is kind of nice, but you still get all 4 seasons. But anyway, the last day, we've got 15 kilowatt hours at the river house. So this is today. So this is since midnight. So what is that? 14 hours or so thus far. We're at 15 or so kilowatt hours for keeping the river house cool. 5 for here, although you have to also add in the dehumidifier, which is 4, so 9. So 15 versus 9. And then the game house, which is a smaller place, but it is 4.5. So just kind of interesting to see how these houses are running. I'll keep doing videos like this periodically, and the game house heat pump, which is the exact same one, it's also a Daikin Fit 1.5 ton, which came with a bad indoor coil. It leaked and it took forever to get a new one in. That was annoying. But it should be up and running here shortly, and then we'll be able to watch that. I just have to set the energy monitor up over there. So hopefully this was kind of interesting, just a different way to actually see what you can do with the energy monitors. And I mean, I was learning with you to see what all's going on here. And you can look at the total usage for the day here. So we know there's 4.5 here, so half the usage of the game house is cooling. And then this is 9 and this is 15. So the vast majority of the usage here is cooling right now, but it's an 85-degree day. So not really surprising. So I hope this was interesting. I'll see you on the next one. And the Emporia, it's a nice little product. So, and I love that I can look at multiple houses easily in the same account. So have a great day. I'm Nate Adams. Bye-bye.